Hello everyone, my name is Adriel Alcala and I will be demonstrating my sort, which is the Timsort. So what you want to have is an array of cards. I mean, in actual data you'll be having numbers, but for this example we will be demonstrating using cards. And then you just want to place them out. Preferably, well, for this example I will be using shuffled cards. So the Timsort is, what it is it is a sort method that combines both, it combines two sort methods, the bubble sort and the merge sort. So how it does this is you have your data right here, right? The cards will be acting as our data. You're going to split these into how many lists you want. For this example, I'll be using 3 lists. So 1, 2, and then this is my third one. I have an uneven amount of cards, so it will be like this. Also, sorry, I'm using my other hand to hold the camera. What you want to do first is, now that these are sorted into lists, what you want to do is you want to run the bubble sort through all of these lists before anything, because what you want is for each list to be sorted before we move on to the next step. So to do that, we will be using the bubble sort. So for this list, the bubble sort is you compare 2 cards and you swap them around like this. 3 is smaller than 5, so it stays here. But then you go on to these. Now you're swapping these. 5 is bigger than 4, so you're going to swap them like that. And then you're going to run it through. So then you're going to check each card again. So 3 smaller than 4? Yes. Is 4 smaller than 5? Yes. So this list is sorted. Now for this one is actually almost sorted. So is 1 smaller than 2? Yes, so that stays. But with these, is 2 smaller than 0? No. So you swap these around. And then now that you're at the end, you have to go through it again. So you go back here. 1 is not smaller than 0, so you swap this around again. And then you go through it again. So is 1 smaller than 2? Yes, so that stays. And it should all be sorted. Now for this one, okay, this is almost sorted anyway. The thing about the Timsort is that it works best with real world data. And sometimes in real world data is already shuffled a bit like this. I mean, not shuffled, but in order. So you go through it again with the bubble sort. 9 is bigger than 6, so you swap that around. 9 is bigger than 7, so you swap that around. And 9 is bigger than 8, so you swap that around. And what you should have at the end, depending on your amount of, depending on your list, is however amount of lists you have, but they're all sorted, right? So now that you do this, we're just gonna ignore this one for a second and focus on these two. This is where the merge sort comes in. You take the pointers of each card, which are like this, and it's kind of like the bubble sort. So these are the pointers. These are the first of everyone. And then you just compare them. So between these two lists, the pointer of this one, 0, is smaller than 3. So you take the 0 from here and you move it here. Then 1 becomes the new pointer of this list. 1, you swap between these ones. And the reason I'm pulling it out is to show that, you're only looking at these. 1 is smaller than 3, so 1 will go here. This becomes the new pointer. 2 is smaller than 3, so 2 will go here. And because there's nothing on this list anymore, you can just put everything from this list as it is. Okay, now that we have this, hold on, let me just move these cards over here. Okay, now that we have this, we should have, well, in my case, it's 2 lists. You run the same process over, and even if you have more lists, this is how it'll go. You just compare between 2 lists. So you take the pointers of each list. In my case, is 0 and then 6, which is smaller. 0 or 6? 0. Take the pointer. 1 is smaller than 6. 2 is smaller than 6. And then you take the pointer again. And you just keep doing these comparisons. So 3 is smaller than 6. 4 is smaller than 6. And 5 is smaller than 6. So luckily for us, that was actually pretty simple. But with the Timsort and any array of data, it should just go like that. So just to recap, we had it separated into lists. We ran the bubble sort through all of these to sort these. So all the lists will be sorted. And then you take the pointers from the first two, keep going like that, compare. And at the end, you should have a sorted list. And here you go. You can see 0 is smaller than 1. Yes. 1 is smaller than 2. Yes. 3 is smaller than 4. 4 is smaller than 5, and so on. So that is my sorting method.